Kosmos arrived with the quiet confidence of a machine that knows it read 1,500 research papers before most of its human colleagues located their coffee. Future House, now hiding behind the more commercially presentable banner of Edison Scientific, introduced it as an AI scientist, which is a polite way of saying they built something that behaves like a researcher who never sleeps, never complains, and never wastes an afternoon arguing about funding on Twitter. Instead, Kosmos absorbs vast libraries of knowledge, runs more than 40,000 lines of analysis code per run, and produces work that beta testers say feels like 6 months of PhD-level effort compressed into a single sitting. The unsettling part is that this is not marketing exaggeration. This is just what the thing actually does. The reaction from the scientific world has ranged from admiration to the type of existential discomfort usually associated with finding a spider in your shoe. Plenty of experts have spent the past 2 years insisting that large models cannot do serious scientific reasoning, only to pivot overnight and declare that AI can apparently do physics now. Watching experts update their worldview publicly is unintentionally entertaining, especially when you can see them wrestling with the fact that a machine is gaining analytical skills quicker than their own frameworks can accommodate. It is the academic version of someone saying, "I told you it was impossible," while standing next to a system that has already proved them wrong. Kosmos is not just playing with toy examples either. It reproduced a finding about metabolism in hypothermic mice that had not yet reached the public literature. It identified a humidity threshold in solar cell engineering that researchers normally discover only after months of experimental misery. It matched mathematical rules in neuronal connectivity that neuroscientists had mapped out the slow, painful human way. It proposed that higher levels of the antioxidant enzyme SOD2 may reduce fibrosis in heart tissue, which is the sort of insight that forces cardiologists to grimly accept that a machine has just wandered into their territory. And when Kosmos examined proteomics data from Alzheimer's patients, it produced a new analytical sequence for understanding why tau proteins accumulate in vulnerable neurons, which researchers later validated in human cases. A 90-year-old scientific puzzle approached by a system that does not even have a brain. With an accuracy rate hovering around 79%, Kosmos is not infallible. It has moments where it bounds after irrelevant patterns, like an enthusiastic retriever chasing a dust mote. It can latch on to spurious correlations with the misplaced confidence of a first-year student who has just discovered statistics. Yet even these moments have a strange creative value. When a human leaps into a speculative idea, it is often framed as visionary. When an AI does it, everyone panics about runaway hallucinations. The truth probably lies somewhere in between. Kosmos makes leaps at industrial scale, and buried among the misfires are insights a cautious researcher would never consider. The real tension begins when people imagine what happens once systems like Kosmos begin checking their own conclusions. Scientific research has always relied on slow cycles of reading, thinking, and verifying because humans cannot process information at machine speeds. Kosmos is the first public sign that this bottleneck will not last. If it can generate hypotheses, test them, refine them, and repeat, it will compress the scientific cycle into something unrecognizable. At that point, the question stops being, what can the machine do? And becomes, how do we keep up? It would be naive to assume the public version is the cutting edge. Somewhere behind closed doors, a private lab has almost certainly run deeper experiments, probably while telling investors that everything is still in early testing. Physics is the field most likely to feel the impact first. Human physicists spend years wrestling with quantum gravity models, dark matter theories, and high-energy parameters, often slowed by institutional inertia and the delicate politics of academic reputations. Kosmos has no such limitations. It scans, cross-references, and simulates with complete indifference to theoretical fashion. If a machine can explore thousands of scenarios overnight, the old rhythm of physics, where progress waits patiently for the old guard to retire, begins to look like a historical curiosity. This rapid shift explains the increasing strain in scientific commentary. It is difficult to present a stable opinion when the technology you are describing evolves faster than your scripts, your slides, or your confidence. Some commentators are oscillating between skepticism and awe, and the result is a type of intellectual whiplash that is easy to spot once you look for it. The ground is shifting under them. Kosmos simply revealed how quickly. The corporate angle complicates everything. Kosmos costs $200 per run, which means we have created an economic layer around scientific acceleration that feels more like a luxury service than a global public good. The research community is already uneasy about the concentration of scientific power inside a handful of private companies, especially when that power includes tools capable of replacing months of human labor with a single automated cycle. Open source alternatives will appear, but they will not appear by accident. They will require communities who are willing to pour time into building something powerful enough to compete, and nobody knows how long that will take. The most haunting thought experiment is imagining what someone like John von Neumann would have done with Kosmos. He built the foundations of modern computing, advised on nuclear strategy, contributed to quantum mechanics, and still found time to reshape economics, often before lunch. Hand that mind a machine capable of reading thousands of papers a day, generating hypotheses at industrial scale and iterating without fatigue, and the 20th century might have unfolded very differently. It is possible that entire scientific fields we consider future work would already exist. Kosmos is not just a productivity tool, it signals a shift in the nature of scientific ability itself. A machine can now operate at a scale that no human can match, and this creates a future where scientific reasoning becomes a hybrid effort between human insight and mechanical scale. The world is witnessing the emergence of a new kind of scientific agent, one that does not replace human minds, but forces them to reconsider their place in the ecosystem of knowledge. Whether this becomes the greatest opportunity in scientific history or a confusing transition filled with uneven access and unanswered questions depends entirely on how humans guide it. Kosmos is only the beginning. What comes next will test our imagination, our ethics, and our sense of control over the very process of discovery.